This morning I've been fielding a lot of questions about this climate skeptic case that I put forward involving, first of all, this notion that the infrared radiation coming from the sun will be at least partially reflected by the CO2 molecules in the atmosphere uh, in relative proportion to the amount of sunlight that bounces off the Earth is shifted into the infrared end of the spectrum and then bounces off the CO2 in the atmosphere back towards the planet. It's been causing a great deal of confusion with a great deal of people online. I was debating one person who I think is a subscriber to my channel, and he brought up this point again, but it's more to do with absorption, re-emission than, strictly speaking, reflection off of electrons. I've repeatedly had to feel this one in particular many times at this point. We have no way of knowing with experiments. We can't see a photon bouncing off an electron as opposed to a photon being absorbed and then instantaneously re-emitted by an electron. I happen to think for quantum mechanical reasons that no photons actually bounce off the surface of an electron, whatever that means. My opinion on that is that any interaction of an electron with a photon will cause the electron's wave function to collapse, and then via the uncertainty principle it accelerates to superluminal velocities, i.e. tunnels to a different location. What shows up in the location where the electron is tunneled from is, I suspect, another electron, which via the exclusion principle has an energy level, i.e. an energetic content in terms of photons, or a photon that's almost the same, or very nearly the same as the electron that's departed. And I think the quantum mechanical case for that process, and none of this stuff, by the way, is even really all that important to the argument. The quantum mechanical case, it doesn't matter particularly if it's not an absorption and re-emission case in any case. That's not so relevant to all this, really. What is relevant is more this idea related to the exclusion principle and the fact that Earth's gravitational field can only hold so many atoms of any, or it can only hold so many particles, right? So the number of protons, neutrons, and electrons that the Earth's gravity can sustain as an atmosphere is determined by the Earth's mass. The Earth does lose mass over time. It's reported to lose about 1,000 tons, I think, of mass every year, if I've got that right. Though obviously by the logic of climate scientists, that would, if anything, weaken the greenhouse effect. But I think for these purposes, the Earth's mass can be treated as a constant, more or less. And yeah, we can therefore conjecture, but it doesn't matter what the specific chemistry of the atmosphere is. What matters more is its content in terms of protons, neutrons, and electrons, because it's atomic nuclei that hold on to radiation. Likewise, some radiation is also bouncing around inside atoms between the nucleus and its electron density, and for this reason the electron doesn't fall into the nucleus. And yeah, therefore it doesn't matter if our atmosphere is made of uranium. If we have a uranium atmosphere, for whatever reason we would, Earth's gravity being constant can hold on to a certain number of uranium atoms. Those could each hold a greater amount of energy than either an oxygen or a nitrogen atom, but Earth's gravity can't hold on to as many uranium atoms as it can hold on to oxygen and nitrogen atoms, right? So that's the equivalence principle. Yeah, and that's how it would act in that sort of scenario. The other objection that I had to field from somebody today on Quora, who was giving really quite a misleading idea about incoming solar radiation. They were trying to argue that the majority or the largest part of incoming solar radiation is visible light. That is not the truth. Don't let anyone tell you that. The largest part of incoming radiation to the Earth, 49.6% of it, is infrared radiation, and that's infrared radiation, not just the short wave of the infrared either. That's the whole of the infrared spectrum forms the largest part of incoming radiation. they correctly pointed out that carbon dioxide, or I think they were correct on this. I might just quickly Google it. See what wavelengths carbon dioxide absorbs and emits again. I think it's about in the 2000 nanometer range, if I remember correctly, or if this person was correct. Wavelengths absorbed by CO2. Between 2000 and 15,000 nanometers. So yeah, I mean, the graph I gave, which gives a ratio, I gave back a graph that gives a ratio of incoming solar radiation against black body radiation. Yeah, that goes right up to the 10,000 nanometer end of the spectrum. So yes, this person was giving misleading information, and indeed, quite an equivalent amount of incoming infrared radiation must be bouncing off the CO2 in the atmosphere back into space. We can use the term bouncing with relative ease. What it really does, it absorbs an incoming photon and it ejects another photon to try and maintain a energetic equilibrium, right? So every particle in the universe always wants to try and reach its ground state, a state of lowest energy. It doesn't actually want, quote unquote, to absorb photons. It wants to emit photons, if anything. So if you put any particle into an energetic vacuum, i.e. an environment in which there are no photons around, that particle will lose photons and it will reach absolute zero, right? So this is of course what happens when we cool things down. That's the definition of cooling. We move a material to an environment that has a lower energetic background, less heat, right? Less photons to absorb, and then the material loses photons in addition to that. Tries to reach its ground state. So yeah, this distinction between absorption and emission and all this stuff, that can be neglected, because we've got constantly more photons coming in, constantly photons going out. What really matters is, of course, the number of photons coming in. So what really matters is, which, yeah, for the reasons I've just said, right? For this reason to do with the energetic background, increase the number of photons per square meter of Earth's surface, then you'll get warming. Absolutely. Move it closer to the sun, of course it'll get warmer. But yeah, the specific chemistry of the atmosphere makes no difference at all. None at all. Yeah, and then someone else was saying, also making this point, that they're emitted out again in all directions, which is a point of unbelievable slipperiness, I'm sorry to say. That would be as true now, wouldn't it, for the infrareds being reflected from the planet's surface back up into the atmosphere. You get some reflected from the surface, then that will be emitted in all directions up into space as well, some of it. Likewise, some of the radiation coming from space, that'll be emitted towards the Earth when it hits CO2 in the atmosphere. The majority of it will go back into space though, because via quantum electrodynamics we only have partial reflection that we need to consider for those cases. Yeah, and partial reflection, that's given by, very simply, photons hitting material. They don't reflect straight out again like most of them do, in fairness. Usually they just bounce around in the material and eventually leave after having been attenuated, but via all sorts of quantum mechanical intermediaries, mostly to do with getting exchanged with lower energy photons in most cases. It eventually leaves as a different sort of photon than what came in, and you have to treat it all as virtual particles, and in sort of the quantum gravitational, if you like, estimations of all this, it becomes very, very thickety and complex. But yeah, nonetheless, the idea it is, the reciprocal is as true as the greenhouse effect. there is this reverse greenhouse effect, if you like, which yeah, is true by precisely the same logic that the greenhouse effect is the truth, if you see what I mean. So there's that to consider about climate science, and I'm sorry to say, like, a lot of people have been, in essence, shouting at me and being abusive for this. Like, you should be more sensible. You're a climate denier. Like, no, you should actually start doing science. It's like, if you don't entertain skepticism in any field of so-called science, you are not doing science, and that is the end of it.